Welcome back, class. So we're continuing with Chapter 1, Understanding Subdivisions of Number System, Estimated, and Accuracy. We're gonna go to the next topic, which is decimals in this section. And so our learning objectives is to determine the value of decimals and accurately round decimals. And that's all we're checking on this section. So decimals. Decimal is a fraction in which the denominator is the power of 10. So remember that's the number below the bar. In a fraction, such as 10, 100, 1000, etc., is a decimal fraction, or more simply, a decimal. So for example, we have 2/10 is a decimal fraction. Basically, the decimal fraction will represent where the 2 is going to be located. In regards to that decimal point. So the Arabic expression of 2/10 is 0.2. An understanding of decimals is crucial to pharmacy calculations because most medication orders are written using the metric system, which uses decimals. Remember that the numbers to the left of the decimal point are whole numbers, and the numbers to the right of the decimal point are decimal fractions, part of the whole. Okay, so remember that anything after the decimals, for example, this 2, it's part of the whole. So in this case, a 2/10, a whole would be 10/10, right? So 2/10, if you think about the pie incident, would be 2 pieces of the whole pie, which was 10 pieces, right? So let's move on. So reading and writing decimals. A decimal is read by first reading the whole number to the left of the decimal point, if there is a 1, then the decimal point saying and or point, and then the decimal fraction to the right of the decimal point. When there is no whole number, a 0 should be placed to the left of the decimal point. This 0 is called a leading 0. So it's very important in pharmacy whenever you guys have a leading 0, you should make sure of that, because in pharmacy it's very crucial that we don't make mistakes where a medication is in milligrams or whatever it may be. If we don't put at 0.2, and if most incidents people would put 0.2, sometimes we can forget about that decimal and think that the medication is 2 milligrams, while it technically is a 0.2 milligram medication. And that's a big significance whenever you're giving medications to patients, because you can either over medicate them, and in that cause complications in their regimen to get better. So adding and subtracting numbers. When adding or subtracting decimals, place the numbers in columns so that the decimal points are aligned vertically. Add or subtract from the far right column to the left far column. So for example, 20.4 plus 21.8. Make sure that these decimals are aligned and keep them that way. Okay, so 4 plus 8 is 12. Carry the 1. 1 plus 1 is 2. 2 plus 2 is 4. And just bringing down that decimal point and putting it in its place. Subtracting. So again, 6 minus 0, 6. 3 minus 8. Since 3 is smaller than 8, we have to go to the 5 and ask for some help. So the 5 converts into 4, and the 3 converts into 13. So 13 minus 8 is 5. Now this is a 4. 4 minus 3 is 1. And then just bringing down that 1 down. And again, since you've already aligned your decimals, you're just bringing that decimal straight down. Okay. When we're multiplying or dividing decimals, so multiplying to decimals as you would whole numbers, then add the total number of decimals places that are in the two numbers being multiplied. Count the number of places from the right to the left in the answer and insert that decimal point. So here you don't have to align the decimal points, okay? You just multiply like if you were multiplying two regular numbers, and then just count the decimal spaces. So this one has 1, 2, and then there's that decimal. So that's 2 decimal places. In the next number, there's only 1 space and then the decimal. So that's 1. So that's going to be a total of 3 decimal places. So once you multiply 3 times 3, 9, 3 times 2, 6, 3 times 1, 3, add a 0 and a place value, and then 2 times 3, 6, 2 times 2, 4, 2 times 1, 2, and then you would add these numbers together. So 9, 12, 8, 2. And then remember we said that there was 2 decimals and then 1. So we're going to add these. So that's going to be 2 plus 1, that's 3. So you're going to move, starting from the last number, move 3 spaces to the left. So there's 1, 2, 3. And that's where your decimal place would go. Okay. To divide decimal numbers, change both the divisor and the dividend to whole numbers by moving their decimal points to the same number of spaces to the right. So in this case, we're going to move. This one has how many spaces? 1, 2, 3, and this one only has 2. That means this one, we're going to have to move it 3 spaces to the right. So see how the 1.45 converts into 1,450. Okay, and then 3.625 converts in 3,625. Okay, so then you're able to divide these numbers together, and then your answer will be 0.4 once you've divided them. So rounding decimals. Rounding is the process of simplifying a number by increasing or decreasing its value. Rounding number is essential for daily use of mathematical operations. The purpose of rounding is to make numbers easy to work with. So it is important to recognize, however, that rounding will affect the accuracy to which a medication can be measured. To round an answer to the nearest tenth, carry the calculation out 2 spaces to the hundredths place. So 5.65, we're rounding to the hundredths place. So this is the tenths place, hundredths place would be the 5. So that becomes 5.7. Okay, so we're looking at the tenths place, looking at the hundredths place. Since it's 5 or greater, it increases by 1. So 6 plus 1 is 7. The same procedure may be used when rounding to the nearest hundred places or thousands place. So if you're rounding to the hundreds place, so you're going to go to the 10th hundredth, which is the 4. So we're going to look to the next number to the right. It's a 2. Since it's less than 5, we're going to leave the 4 by itself. So the answer becomes 3.84. Rounding to the thousandths place. So again, we're going 10, hundreds, thousands place. So that's the 2. We're going to look at the number to the right, which is the 8. 8 is greater than 5. So the 2 will convert to 3. So 0.393. Okay. And the reason why we're rounding decimals, it's because sometimes in pharmacy you can't measure to the thousandths place, or sometimes not even to the hundredths place. So most of the time we'll measure to the tenths place, which is a 5.7. Okay, we'll measure to that number to the right of the decimal. Okay, because of syringes, whenever we're measuring syringes, or we're measuring in liquid format, sometimes it's hard to measure to that hundreds or thousands place. So it's very important to round off. Okay. So round the answer to the following to the nearest tenth place. So we're rounding to the 10th place. So after you've multiplied 3.46 times 7.1, the answer is 24.566. Now the 100th place is the 10th place is the 5. So we're going to look at the number next to the 5, which is a 6. 6 is greater than 5, so that 5 becomes a 6. So our answer is 2.46. Round the answer of the following question to the nearest hundredths. To the nearest tenths again. So multiply these together. There's 1, 2, 3, 4, 5. So we're going to have 5 spaces before the decimal. 1, 2, 3, 4, 5. And again, we're rounding to the 10th place. So looking at the 4 and looking at the 6 next to the 4, it's greater than 5. So we're going to increase it by 1. And this one says round to the nearest hundredths. So the hundredths place is that first 9. We're going to look at the 9 next to it, which is greater than 5. So that 9 increases by 1. So 9 plus 1 is 10. That means that the 5, you're adding a 6 to it. And technically here, we're going to leave that 0 there. And in, we usually don't like to do this in mathematics where we have a 0 after that decimal, because you might miss that decimal and you might not see that 0, so this becomes a 60. We don't like to do that, but with regards to significant figures, which we'll learn later, it's very important for us to keep that 0 there whenever we're measuring for compounding purposes. Whenever you're mixing medications and stuff, it's very important to keep that accuracy, especially when you're weighing information. It's that 0 after the decimal is crucial as a significant figure, but we'll talk about that later. And that's the end for this section. If you have any questions, again, feel free to email me, or that Q&A discussion board is there as well, where you can ask questions, and then fellow classmates, if they have the answers, they can answer it there as well. So let's move on to the next section. Bye-bye.